Hello everybody, and welcome to exercise 2 on page 46 of the workbook. Let's take a minute just to read this question together. They'd like us to find the equation of the tangent line to y equals 3e to the x sine of x minus e to the x at x equals 0. Okay, now this is a type of problem that we have seen before. We know how to find the equation of a tangent line. What's maybe different here is that the function is a bit more complicated than what we're used to. Okay, so let's remind ourselves of what's involved in finding just any line. Okay, if you want to find the equation of a line, kind of the two key things that you need are a slope and a point on the line. Okay, so we need the slope of this tangent line, which means we need to take the derivative of this function. Just to make the notation easier, I'm going to take this y and relabel it f of x. Okay, just so that we have our f prime of x notation available. So to get the slope of the tangent line, we need to start by taking the derivative of this function. Now here's where we need to be a little bit careful with order of operations. Okay, notice that we've got two functions that are subtracted, 3e to the x sine of x minus e to the x. So when we take this derivative, we're going to start by splitting those two pieces apart. And think of those as two separate derivatives that we're going to do. Okay, so starting with the first piece here, the derivative of 3e to the x sine of x, we can split that into a product of two pieces. Think of 3e to the x as our first function and sine of x as our second function. So when we take the derivative, using the product rule, we're going to get the first function times the derivative of the second. The derivative of sine of x is cosine of x, plus the second function, sine of x, times the derivative of the first. What's the derivative of 3e to the x? Well, that's just going to be 3e to the x all over again. Okay, and so what we've written so far is the derivative of this product. And now we come to the second piece. We're going to subtract the derivative of e to the x. That's just going to be minus e to the x. Okay, there's our formula for the derivative. Okay, and so to get the slope of our tangent line, we're just going to substitute in the appropriate value of x. That's 0 in this case. So f prime of 0 is going to be 3e to the 0 cosine of 0 plus sine of 0 times 3e to the 0 minus e to the 0. Okay, and some of you might remember what the value of sine of 0 and cosine of 0 are. If not, you can go to your calculator. But it turns out that sine of 0 is actually equal to 0, so that term goes away. And cosine of 0 is actually equal to 1. So what ends up happening here is that for this first part, we're going to get 3 times 1 times 1, which is 3. This whole second term is going to go away. 0 times 3e to the 0 is 0, and then at the very end we've got a minus e to the 0, which is a minus 1. Okay, that's going to give us a 2, and that 2 that we're looking at is the slope of our tangent line. Okay, so the slope of this line equals 2. Okay, what was the other piece of information that we need to find the equation of a tangent line? We need a point on the line. Okay, and to get a point, we can take our x equals 0 and substitute it into the function itself, okay, which looked like 3e to the x sine of x minus e to the x. Let's go ahead and substitute 0 in for all of those x's. Okay, and here if you do the arithmetic, there's that sine of 0 again. That whole first term is going to go to 0, and we're just going to get minus e to the 0, which is minus 1. Okay, and so a point on the line is 0 and negative 1. Okay, that's just the x and the y value that we calculated there. Okay, so what about the equation of the tangent line then? Let's see if we can write it down. Okay, we're going to start with y equals mx plus b, and the m is just this slope 2 that we found. So we've got y equals 2x plus b, and we're going to use the point that we found to figure out what the b is. So this point has an x-coordinate of 0 and a y-coordinate of negative 1. If we substitute those two in, negative 1 for y and 0 for x, we are going to get negative 1 equals b, it looks like. Okay, and the last step, you just go ahead and fill in that value for b, and our tangent line equation is going to be 2x plus the b that we just found, which is minus 1. So we could just write that as 2x minus 1. And that should be our answer.